Hi, we present MIMI Software, a new dataset for knowledge graph-based question answering with electronic health records. EHIQA refers to query generation task of translating the natural question into specific queries that are executed by database engine on EHR. Since EHR data typically stored in a relational database, existing EHIQA methods generate a SQL query. However, the IDB stores data in primitive manner via complex schemas in order to maximize the efficiency in large-scale data processing and storage. Therefore, SQL has a function such as join to aggregate information scattered across the multiple tables. This characteristic leads to decreased query performance of the model trained on NX SQL pairs when the SQL samples are generated from the complex schemas. EHR can be seen as a knowledge graph of clinical facts, allowing two approaches for EHR QA, table-based QA and graph-based QA. Unlike SQL, SPARQL, which are graphical ranges, does not require a special function to collect scattered information, as Cajun maintains relevant information in a single graph. Our key contributions are as follows. We propose a graph-based EHQA where natural language queries are converted to SPARQL instead of SQL. But on comparison between the two, we consult both table-based and graph-based EHQA dataset, namely MIMI SPARQL. And we test both a simple sequence-to-sequence model and state-of-the-art EHQA model on both dataset, where the graph dataset facilitates up to 34% higher accuracy than the table dataset without any modification to the model architecture. In order to encourage the further EHQA research in both directions, we open source the dataset. To validate our hypothesis, we create a broad EHQA dataset by extending a table-based dataset MIMI SQL. This figure shows query lengths of the broad dataset as the histograms. When the schema becomes compressed while borrowing the original schema of MIMI3, the length of SQL is increased significantly compared to that of SPARQL. As shown in table, regardless of the type of NAQ, the SQL dataset shows competitive performance to its SPARQL counterpart when using the simplified schema. However, when using the original MIMI3 schema, the graph-based approach consistently outperforms the table-based approach. We carefully analyze the reason for graph-based method superiority over the table-based method. Left figure shows when the complexity of the queries increase, the length of all queries increase. But we can confident that the length of SPARQL increases with a slope more similar to NIQs than SQL queries. This result in right figure shows the increased performance gap between graph-based and table-based models for the complex questions. Thank you for listening. For more information about this project, including code and additional results, please visit our GitHub.